Welcome to the Nano Entrepreneurship Network podcast, where entrepreneurs who have transitioned ideas into the marketplace share some of the lessons they have learned and insights on the navigation of the technology development pathway. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Today, I'm joined with Dr. Aaron Santos, President and co-founder of DNP123. Aaron, thank you so much for joining us today. To get us started, can you tell us a little bit about how you got involved in your company and what you do there?
Sure thing. And thank you for taking the time to have us here, Lisa. I think I started like a lot of nanotech entrepreneurs. When I was an undergrad as a science major, I started doing undergraduate research. And I have very vivid memories of going into the science library and looking through the nanotech books. And I remember Engines of Creation and some of the other early books that came out. And was really inspired by that, ended up joining a couple of different research groups. And it's just always been an interest and a passion of mine, going up from graduate school to postdoc and eventually going to teach at Simpson College, where I was a physics professor for several years. At the time I was there, Simpson was starting a new entrepreneurship program called Emerge. We were kind of the guinea pigs for that program, myself. And when I arrived at Simpson, I met Dr. Derek Lyons, who is the co-founder of DNP123. And I was more on the theoretical side. He was more on the experimental side. And we started a partnership that Simpson thought, hey, this might be a good opportunity to teach our students about entrepreneurship. And, if you have a good idea, how do you actually take that and bring it into the real world?
So you became a bit of a poster child for this program. So how did you work with students throughout that process?
So even before we had a company, we were doing undergraduate research. We had a few May term classes where we taught nanoscience. So I would say even just through the curriculum, we were always doing research at some level with the students and exposing them to the latest research. This really formalized it where, we started bringing students in for the summer, doing research with them and trying to figure out not just how to answer questions about nanoscience, but how can we actually make products and bring them into the real world and make them in a way that, people are actually going to get more use out of them than, just publishing a paper like we would have, previously in graduate school.
So I want to talk a little bit about your company, and your website discusses bridging the gap between design and manufacturing by developing a novel technique capable of assembling any structure with nanoscale resolution. Without disclosing any of your proprietary information, can you describe a practical application that would use this technique?
Before getting to a practical application, it might help to give just a little bit of background on what the genesis for our research was. And it started when I was a postdoc in Sharon Glotzer's group at the University of Michigan. And I had a real frustration because our team did a lot of really great research on self-assembly and figuring out how different particles would connect in different ways. But I was frustrated because I felt like if you wanted to make something more complicated than what nature was giving you, you had a real limited set of options. And the example I always gave is, you can make spheres and cylinder nanoparticles fairly easily. But if you wanted to make something in the shape of a puppy, there was no puppy particles. You can't just design the thing that you want to make. What we tried to do was come up with a way of how can we take an inorganic particle and design it in such a way that we can program the assembly of it. And while, having puppy-shaped nanoparticles isn't a huge economic driver, once you create that design ability, it opens up a lot more possibilities for different solutions and being able to rapidly prototype new solutions that solve real-world problems. So for a practical application, we're based in Iowa. We're surrounded by seed companies and organizations, and they have a strong interest in being able to measure genetics, both because of GMOs and just being able to identify traits that are of use for soy and corn and different crops that are grown. And ideally, they'd like to be able to do that in the field. As we were doing customer discovery exercises, we identified this on-site solution as a possibility. And we were able to put together a prototype for genetic detection using the technology we had put together. We were able to do that in a couple of months. The approach that we take really enables you to do that rapid prototyping, to be able to design solutions that wouldn't necessarily be easy to come by just with the conventional nanoparticles that nature would give you. So one of the things we actually found is that the particles we made are conceptually simple enough that we could use them with undergraduate students. So even if you're a freshman student that doesn't have a lot of background in chemistry or physics, you could still come up with a reasonable design for how to connect particles in different ways to solve problems.
You mentioned that you can do it in the field. So is there a readout that you can get on your cell phone? And what is the detection methodology that you're using?
So the particles that we've made are basically nanocubes where each face has been patterned with a specific sequence of DNA. So it's similar to the work that Chad Merkin really pioneered, except the main innovation is being able to put different sequences of DNA on the different faces. And if you're looking for different genes within, let's say, a seed or some corn out in the field, what you can do is bind the different faces and use that to assemble different structures. And based on either the optical signal or a lot of the particles we use are just below the diffraction limit. So you can actually see them under a microscope. I should give the caveat that I think the technology DNP123 is using is great for rapid prototyping. It doesn't necessarily mean that's the end solution that you're going to want to use for a given application. So once we were able to get that initial proof of concept within a couple of months, and then as we learned more about the use case, we ended up pivoting and shifting off the technology. And we actually have a separate spin-out company called Nanobio Designs right now that's focused specifically on genetic detection. They've used a little bit of a different technology. So for example, in our original prototype, I think we were using way more DNA than you'd actually have out in the field. So our limit of detection was much too large to be of use for on-site application. So we were able to redesign that and deploy that new technology out in a separate company.
Looking back, are there decisions you would have made differently?
There are so many. One of the most important things as an entrepreneur is having a high tolerance for failure. Early on, if I had to give some advice to aspiring entrepreneurs, one of the bits of advice I would give is there's no such thing as a technology, especially a nanotechnology, that will work. There is nanotechnology that works, and you know it because you've tested it many times in the past, and it's worked every time. And there are things that you are uncertain about. I think one of the places we got ourselves into trouble early on is being too optimistic and kind of looking with rose-colored glasses at preliminary data without really taking the time to make sure that what we were doing was going to be economically viable. You have to be very careful about making sure that the project that you're pursuing is not a research project. It needs to be something that's fleshed out enough that you can take it out of the lab and have it work in the messy real world with people who don't have PhDs that are going to be running the equipment to make it really useful.
So what has been the role of mentors in your path so far?
Simpson did a really good job of putting us in front of different business leaders, both from their alumni network and several folks that were on their board. I think one of the tricky things, especially doing entrepreneurship in nanoscience, is that there are a ton of entrepreneurs in the software space, and the rules for doing a startup in the software space are very different than the rules for the nanotech space. So I think early on, we had a lot of very well-meaning folks that gave what would have been good advice from a software perspective. But it wasn't really until we started talking to folks who were doing hardware or doing things that were a lot closer to the type of work that we were doing that we really started to get some traction. If I had to call out a specific group, there's a company based in Iowa, not too far from us, called MakeYouSafe. And they're not in the nanoscience space. They're in industrial hygiene, but they're working with both data and hardware, trying to make decisions. And kind of having seen the path that they went down and the success that they had, that was just both inspirational, and it just gives you this feeling like, yeah, we can do this because we've seen people that we know and we trust that have also done it, and there's a definite path there. So that mentorship really is invaluable, I would say.
So, was there any advice that you received that you would pass on to others, or that you wish that you'd listened to and you didn't at the time?
It's funny because every time I ask an entrepreneur for their advice, inevitably the first response is always don't, which probably says something that we're all so stubborn-headed that we went through and did things anyway. But yeah, if I had to give practical advice, pay close attention to who you think are your customers, and don't try to project what they will want in the future. Look at what they need right now. Never ask folks about, would you buy this product, or is this a technology that you think you would end up using? You ask them today, what was your biggest pain point? What are the things that keep you up at night? Because if you can go and solve the problems that they're having today, then you have a real product that's going to provide a real solution. Otherwise, you're asking people to project out forward, and people aren't very good at predicting what they're going to need several years from now, but they're very good at telling you what's a big annoyance and what could solve problems for them today.
So, I was actually going to ask you just that. What is next? What do you see as the next step for your company and for your journey?
That's a good question. So for the past several years, we've mostly been operating as what I would describe as almost a research as a service company, where we have a nice technology stack of particle assembly techniques that we can use to design solutions for nanoscience problems. We've started to spin out a separate company that's doing work specifically on the genetic detection solution that we identified. And there is a little bit of a question of what's next for us. Part of it will continue to be doing those research as a service projects, but we're also looking a little bit more at trying to do more outreach. And I would say our mission is really making nanotechnology affordable and easy enough for anyone to do. And if we can do more along the lines of, making sure that undergraduate students have access to research tools, or even just exposing them to nanoscience and getting them interested in it. That's something we've been placing a lot of focus on over the last 6 months.
So I want to ask you about your workforce and what type of skills you look for in employees. And one step beyond that, advice to students who might be interested in working at a company like yours. What should they do to prepare themselves?
Yeah, so typically we are looking for folks they have some science training, some lab training specifically. So you need to be able to hop into a lab and know how to pipette and do all the standard chemistry lab techniques. Beyond that, I would say the most important feature of a potential researcher that we would hire is critical thinking. So a lot of the data that you get in nanoscience research is very noisy, and we need to know that you're going to be able to look at that with a critical eye and see, hey, there's a real statistically significant difference in the signal to noise here, or no, this is just noise. We need to redo this and adjust parameters to try to improve on that. And I think that's a skill that a lot of times we don't get to teach in our science labs because we're so busy trying to get through the content. And you kind of know what the answer is if you're taking a class because there's something in the back of the book where I already know what the experiment's supposed to do. But getting students into the mindset where, hey, it's all right that I don't have the answer from the back of the book. I'm going to find out what the answer is. Having employees that have already kind of made that leap and are comfortable with that uncertainty, that's the thing I would look most for.
So, Aaron, I want to thank you again for chatting with us today. This has been really great. Do you have any closing thoughts that you'd like to share with our listeners?
There is a lot of work in the nanotechnology space, things that you might not have even heard of or paid attention to. And it's a lot of really exciting things that are coming out. So certainly check out different science blogs and articles to stay abreast of the information, because there's a huge amount of changes coming to materials and other areas, and it's all very exciting. And if you are looking for new careers and new opportunities, it's a place I would look first if I was a young person.
If you're interested in joining the Nanotechnology Entrepreneurship Network, please go to nano.gov/nano entrepreneurship network or email nen@nnco.nano.gov.